Numericals on common drain amplifier, also called as the source follower. Here we have presented the design of the common drain amplifier. The figure A shows the common drain amplifier wherein we have applied the input signal via a resistance R signal and a load is connected to the source terminal and the output voltage is measured across the source. The equivalent T model is also considered in the below figure wherein we have included the resistance small r naught. These are some of the design equations that we need to remember in order to solve the numericals. We know that the input resistance is infinite. The gain of the amplifier is obtained by RL divided by RL plus 1 by GM. R0 is equal to 1 by GM, and if we want to compute VGS, that is the gate to source voltage, that is computed as V signal multiplied with 1 by 1 plus GM into RL, and the equation for the gain of the amplifier is equivalent to overall voltage gain. So these two equations remain the same. The value of R0 is computed as VA by ID, where ID corresponds to the DC drain current. To compute the DC drain current, we have the standard equation wherein we have the value of Kn, which is equal to mu n multiplied with COX, that has to be recalled. VOV corresponds to the overdrive voltage, which is equal to VGS minus VT. The value of GM can also be computed as 2ID by VOV. GM is basically the transconductance. So these three equations, if you observe, that is the equation for the drain current, the equation for the transconductance GM, the equation for the small value of R0, these are the standard equations which we have seen in almost all type of amplifier configurations. So if you refer to the first tutorial which talks about characterization of amplifiers, I have dealt with these three equations there. So moving on, let us look into the first numerical. The first numerical says that it's required to design a source follower that implements the buffer amplifier which is shown in the figure, that is this figure, and if the MOSFET is operated with an overdrive voltage of 0.25, at what drain current should it be biased, and also find out the signal amplitude of the output and the signal amplitude between the gate and the source. So in the question, what they are asking is, they have mentioned you the value of the overdrive voltage. They are asking you to find out the drain current, that is the drain current at the bias point, and they are asking you what is the output voltage and the voltage between the gate and the source. Now in order to compute the value of ID, what we require is, we require to know the value of overdrive voltage and the value of GM. To compute the value of GM, we are computing it as R0 to be equal to 1 by GM. R0 is given to be equal to 100 ohms in this particular circuit, and GM will be obtained as 10 milliamps per volt. From there, we can compute the value of the drain current as ID to be equal to 1.25 milliamps. To compute the output voltage V signal into GM into RL divided by 1 plus GM into RL is the equation used. We know that V signal is equal to 1 volt from the circuit. RL value is equal to 1 kilo ohms. Substitute the value of GM that you have obtained and you get the value of output voltage to be equal to 0.91 volt. To compute the gate to source voltage, we have the equation which we have seen in the design, which is equal to V signal multiplied with 1 by 1 plus GM into RL. So this will give us 1 into 1 divided by 1 plus 10 milli into 1 kilo ohms, which is equal to 91 millivolt. This is one of the simplest numerical which you can find in the source amplifier circuit or the common drain amplifier. The next numerical says that a MOSFET is connected in the source follower configuration and is employed as an output stage of the cascade amplifier, and it is required to provide an output resistance of 200 ohms, and if the MOSFET has Kn dash to be equal to 0.4 milliamps per volt square and is operated at an overdrive voltage of 0.25 volt, find the W by L ratio, that is the transistor aspect ratio, and also specify the DC bias current ID. And if the amplifier load resistance varies over the range of 1 kilo ohms to 10 kilo ohms, what will be the range of the overall voltage gain for the source follower? In this particular question, R0 is mentioned, which is equal to 200 ohms, Kn dash is mentioned, overdrive voltage is mentioned. And they have also mentioned that RL varies from 1 kilo ohms to 10 kilo ohms, and we have to compute the overall voltage gain and W by L. To move ahead, we need to compute what is the value of GM, because GM will give us the value of the aspect ratio. So R0 is equal to 1 by GM that we have seen from the design, and this will give us a value of 5 milliamps per volt. We also know that GM is equal to Kn dash W by L into VOV. So that gives us the value of the aspect ratio to be equal to 5 milli divided by 0.4 into 0.25 milli, which is equal to 50. ID, that is the drain current at the bias point, is equal to half Kn dash W by L into VOV the whole square. So substituting the values of the aspect ratio, VOV and Kn dash gives us a value of drain current equal to 0.625 milliamps. It is mentioned that the value of load resistance varies. So when you compute the value of the overall voltage gain, we will have two different values. So first find out for a value of 1 kilo and then find out for a value of 10 kilo. The equation for the overall voltage gain is equal to Gm into RL divided by 1 plus Gm into RL. In the first case, I am substituting RL to be equal to 1 kilo ohms, and that gives me a value of 0.833. Whereas in the second case, I am substituting a value of 10 kilo ohms, and that will give me a value of 0.98. So when the load resistance varies from 1 kilo ohms to 10 kilo ohms, the overall voltage gain varies from 0.83 to 0.98. Coming to the third numerical. The third numerical says that referring to the T model of the common drain amplifier, show that by taking R0 into account will give you a value of open loop circuit gain to be equal to so much. And we have to also recall that R0 is equal to VA by ID and GM is equal to 2ID by VOV. We need to find out the value of AV0 in terms of VA and VOV. And for a technology for which VA is equal to 20 volt, what will be the maximum VOV at which the transistor can be operated while obtaining AV0 greater than or equal to 0.99. Now, equation for the open circuit voltage gain is equal to GM into R0, 1 plus GM into R0, and AV is equal to R0 divided by 1 plus GM plus R0. This value is obtained, as you can see, this equation 1 and this particular equation is the same, just that we have rearranged it by considering AV0, that is the open circuit voltage gain, is equal to the gain of the amplifier, considering that the load resistance is infinite. And these two parameters are already given in the question. So to find the value of AV0, what we will be doing is, we will be substituting the value of R0 and we will be substituting the value of GM. So you can see here we have AV0 to be equal to R0 divided by 1 by GM plus R0. So substituting, we obtain the equation of AV0 to be equal to 2 VA divided by VOV plus 2 VA. So that is the value of the open loop circuit gain, which is denoted as equation number 2. And they have also asked us, saying if the value of VA is 20 and AV0 is equal to 0.99, what will be the value of the overdrive voltage? So what we are going to do is, in the equation 2, we will be substituting the value of VA and AV0, and this gives us a value of 0.4 volts.